Hello again, my name is Tomás Eochagaín and you're most welcome. Thank you for joining me today now for the third session of the Leaving Cert Maths revision. Hope the first two have been helpful, and if you're just joining now, you're most welcome as well. We're going to look at the area of trigonometry, and what I've done here is I've taken all of the various aspects of trigonometry that the examiners are allowed to ask. I've taken them in small chunks, piece at a time, and we'll work through them. And at the end of the session, we'll go through some recent exam questions to show how all of the skills you've learned can be applied to Leaving Cert Maths questions. So what I have here is I've got well, behind me you can see Griffith College campus, but I'm going to actually change my view now, and I'm going to share with you my notes, and hopefully they're here. And I'm looking at the notes here. So the notes are trigonometry. Hopefully you'll have the notes. If you don't have the notes, they're available on our website, griffith.ie, www.griffith.ie. Go to the maths section there, scroll down and go to the resources. And you should be able to print out the notes from today in this area here. So we're going to start now with trigonometry, or triantánacht. We're going to go through some triangles and angles. So the first section is just some definitions, really. And the definition of a triangle is really just a two-dimensional figure bounded by three sides. So 1, 2, 3, that's a definition of a triangle. It's got a close. And that the three angles, A plus B plus C, equals 180. And no one side can be bigger than the other two. So no matter how big this side is, it can't be bigger than the other two, or it wouldn't join. So that's the definition of a triangle. There are different types. Triantánacht comhglaseach, this is an equilateral triangle where you've got the three sides the same, three angles of 60, three sides the same, and the double dash marks show that they're equivalent. So equilateral triangle or triantánacht comhglaseach. Now, an isosceles triangle, two of them are the same, two of the sides are the same, C and A are the same here, and two of the angles are the same, triantánacht comhglaseach. So we've got two sides and two angles. Note that the side A is opposite the angle A, side C is opposite angle C, and the same for B and B. Doesn't matter where you start, but if you call this C, then the angle opposite must be C. Once you name one of them, you also name its angle. Or if you name the angle, you also name the side. Just bear with me. This is an oblique angle, or an angle that's a triangle that's an oblique triangle. Sides aren't the same, the three are different, and you've got the A, B, and C there. Note each lettered side is opposite the same lettered angle. That's really, really important. So A opposite A, C opposite C, and B opposite B. Here's a right angle triangle, or triantánacht drunilach. You've got a 90 degree, or a drunilog there, 90 degree in the corner, and you've got the three sides, A, B, and C. Again, A opposite A, C opposite C, and B opposite B. So that's the definition of a triangle. Acute angles, where the angles are all less than 90. There's a triangle with those. And this one here, you've got a bigger than 90 degree angle on this one, and the other two angles make up the rest of the 180. This is a theorem. Well, it's not a theorem, I suppose it's a proof, but it's also a fact that basically A, B, and C must add up to 180. But also B and E here, that angle taken on the full line, that equals 180. So B plus E must be the same as A, B, and C. Or B plus E must be the same as B and A and C. So B, A and C must be the same as B, E. E must be the same as A and C. A and B and C is 180. B plus E is 180. If we take the B's in common out of it, we'll get C plus D, C plus D is down here as well. That's another 180. But E, this angle here, must be the same as these two, because these two plus that is 180, and that plus that is 180. And similarly down here, if we take the angle D, D plus C is 180, but D plus B and A is 180. So D must equal A plus B. And we'll use those theorems as we do some of the questions. So that's just, I suppose, a summary of what the triangles are and some of the language in it. This is a new area, so when I start a new topic, there's always just a blank screen like this with just a title page in it. There's no other mathematics in it. So this is a new area, and you can start the video here if the others are fine. So these are trigonometric functions, or 5 minute Trigonometry, and Sine Cos and Tan, or Sine Cos and Tan. We start here with a right angle triangle, and remember that again, A opposite A, C opposite C, B opposite B. Sine, or sinus, is defined as the opposite over hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. So let's see what that means. Let's imagine that we're interested in the angle A. If we're interested in the angle A, well then the thing that's opposite A would be called the opposite. And the thing that's the longest, that's opposite the 90, is always called the hypotenuse. And the other one is called the adjacent, because it's near A, whereas this is further away. So adjacent, opposite, hypotenuse. And it starts by figuring out what angle you're looking for, the A you're looking for. The opposite of A is over here, okay? And that makes it opposite. Whereas the opposite of B is here. But we're just interested in the angle A for the moment. So we start with A and we call that opposite, adjacent, and hypotenuse. Or as Gaeilge, that's Orcorach, Congrach, and Hexagon. So this page here, it's in your book, or certainly this part anyway, Os Gaeilge and Os Béarla. So we can look at the definitions of the sine. The sine is a function, it's a trigonometric function, and you get the sine of an angle, this angle here, A. The sine of it is given by the opposite over hypotenuse, opposite over hypotenuse. So in this case, A over C. The cosine, cosine here, is given as the adjacent over hypotenuse. And the tan is the opposite over the adjacent. So we're going to keep that. That's a set of tools or tricks for us. It's our toolbox. It's in the log table, so we don't need to learn it off by heart, but we'll probably use it so often that we do. And we're going to keep that because it's a page we'll refer to again and again and again when we're looking for the sine, the cos, and the tan. So let's consider angle A. If this is angle A, the first thing you do is you draw this arrow, and that defines this as the opposite. So go away from the A, it's the side A, this is opposite. This is the longest side because it's opposite to 90, so this becomes the hypotenuse, and this becomes the adjacent. So in this case, sine A, sine A, this one here, is opposite over hypotenuse, A over C. Because we've looked it up here and we said, yeah, sine is opposite over hypotenuse, A over C. Cosine A, the cos of this angle, is adjacent over hypotenuse. That's B over C. And tan, you look up tan, is opposite over adjacent, A over B. The hypotenuse is always opposite the right angle, so that defines that. It's always the longest one. Okay. Now, let's say they give you the triangle and it's drawn like this. And they say, let's consider angle B. Well, you just get the angle B and you draw a line from it. And then this becomes the opposite. This becomes the opposite. The longest one is the hypotenuse, and this one is the adjacent, or Congrach, or Corach, and Hexagon. So now we can look at it again and say, what's sine of B? Well, sine of B is defined as opposite over hypotenuse. So that would be opposite over hypotenuse, B over C. Cosine is adjacent over hypotenuse. It's A over C. And the tan is opposite over adjacent. So these values depend on which angle you're looking for. Okay, let's look at the next topic. The next topic is inverse sine, cos, and tan. Sin inversa, cos inversa, and tan inversa. So let's look at those three now. They're symbols. You'll see those in your calculator. And we saw earlier today that they undo a sign, so they're the opposite in a way. Just as addition and subtraction cancel each other out, and multiplication and division cancel each other out, sine and inverse signs cancel each other out. So let's look at this. Sine and inverse sine are related operations as follows. Sine theta is 5 over 13. Well, how do we know? Well, there's a 90-degree angle. There's theta. So this must be opposite. That's the longest side. This must be hypotenuse. This must be adjacent. Sine is defined as opposite over hypotenuse. So sine theta is 5 over 13. But theta is the angle that has the sine of 5 over 13. Or another way of doing that is if I just take if I want to get rid of that sine theta there, I can take the inverse sine of it, inverse sine, and do the same here. And the inverse sine and the sine cancel, so I get theta is equal to inverse sine 5 over 13. Keeping it in the same order. So theta, in English, I would say theta is the angle that has a sine of 5 over 13. So here we've got sine theta is 5 over 13. Cosine theta is 12 over 13. How do we know that? Well, that's opposite. This must be adjacent, and this is hypotenuse. And cosine is adjacent over hypotenuse, the 12 over 13. Or theta, if we got rid of that, with an inverse cos, is inverse cos 12 over 13. And tan is the opposite over adjacent, so 5 over 12. If I wanted to get rid of that tan, I would put in an inverse tan here, and inverse tan here, and I'd end up with theta equals, because they'd cancel, inverse tan 5 over 12. So a sine and inverse sine are related. We can see that the sine of the inverse sine is theta, inverse sine of sine is theta. And the same for cos. Cos of cos inverse disappear, inverse cos of cos disappear. And the same for tan and inverse tan. So it's handy being able to do questions like that and just get rid of the term that you're not particularly interested in. So if cos theta is equal to 0.5 and you want to find theta, you can say inverse cos, and then they'll cancel and you'll get theta is equal to inverse cos 0.5. This you can put on a calculator, this you can hit on a calculator, and you get your answer. So that's fine. All the work is done. So we can find theta, the angle theta in the right angle triangle, knowing the lengths of the sides. So let's say that sine theta is 5 over 13. This is opposite, and this is hypotenuse, and this is adjacent. We can take the inverse sine of it and the inverse sine of that. They'll cancel. So I just type 5 over 13 on my calculator, get the answer, and then hit inverse sine. And if it's set at degrees, I get 22.62, which looks about right. Similarly, we can find the angle theta in the right angle triangle as follows. If it's cos, this is opposite, this is adjacent, this is hypotenuse. And again, we can get rid of the cos by having an inverse cos in front of it. And they'll cancel, and we'll get inverse cos of that. 12 over 13, hit inverse cos, second function cos on your calculator, and you get the same answer. So solving for theta, you can see here that we've got sine, cos, and tan. The thetas are the inverses, and the thetas are always 22.62 in this particular triangle. And that links some of the trigonometric functions of sine, cos, and tan to their inverse cos, inverse sine, inverse tan. So let's take a breather. What we're going to do now with all that information is we're going to look at exam questions that come up. They come up in two big forms, really. There's generally questions on right angle triangles, and then there's questions on triangles in general that are not right angle triangles. So on this topic, this one here, right angle triangles only in this particular subsection. So Trianton Dronilak Awain. So a right angle triangle is one that has a hypotenuse. It has a 90-degree angle here, therefore you've got this, and you've got two other sides. Each lettered side, if you call this A, well then this must be angle A. If you call this C, this must be angle C, and if you call this B, this must be angle B. Angle B, side B, side C, angle C. Really important for that to happen, or else none of the equations that follow work. Now, when you're solving right angle triangles, you have this toolbox. You have a toolbox that says A plus B plus C, the three angles, add up to 180. Also, you have Pythagoras' theorem that says the square of this side is equal to the square of the other two sides. So for example here, if this is the 90-degree angle, Pythagoras says b squared plus a squared is c squared, or a squared plus b squared is c squared, depending on which way you write it. But the two of these, the square of this, the square of that, add to the square of the one on the opposite the 90-degree, the hypotenuse or the Hexagon. So they're the rules we're going to keep. We're going to keep that as our toolbox when we're answering these questions. When they start with a triangle, remember that a triangle really has 6 bits. It's got 3 angles and 3 sides. And in the Leaving Cert, what they do is they give you some of the bits of the triangle, but not all of them. And you're to figure out what bits are missing. So typically, they will give you, for example, they might give you the angle C. They might say it's 90-degree, and they might give you 2 of the sides. And you've got to turn it into something else, knowing all the sides and all the angles. So in here you don't know 2 of the angles and you don't know 1 of the sides. Here you know them all. So that's really what your task is. So let's look at the various options that they can give you. We'll start with a right angle triangle with the following sides. They say B is 8 and C is 10. So they're telling me that's 8 and that's 10. And it's a right angle triangle, so that's 90. So they've told us 3 things there. This must be the hypotenuse because it's opposite the 90. B is 8. I don't know A and I don't know B, but they want us to find the length A. So this is the one I'm looking for. And how can I find that? Well, I look at my toolbox and I say A plus B plus C. This is useful if I know 2 of the angles and don't know the third. I only know 1 of the angles, so I'm not going to be able to find that too easy. But this says the hypotenuse squared is side 1 squared and side 2 squared. This is a 90-degree angle. It's Pythagoras. So this says that this squared plus this squared is 10 squared. So b squared plus a squared is 10 squared. But I know that b is 8. So this looks promising. So I can get 10 squared, the hypotenuse, is a squared plus 8 squared. 8 squared is 64. So 100 is a squared plus 64. I can tidy this up and say a squared is equal to 100 minus 64. And that's 36. And I get the square root, a is 6. So that's that question done. What did I do? I went in, they asked a question, I looked at the tools that I had, I found out which one worked, I plugged it in, and I got the answer. Okay, example 2. Find the angle A. How do I find that angle? Well, I'm told that this is 90. I'm told that this is 6, and I'm told that that's 6 and that's 8. If that's the angle A that I'm interested in, this must be opposite. This must be hypotenuse, and therefore this must be adjacent. And it says find A. Well, I look here and I say A and B and C, but I only know C, so don't think I can use that one. Pythagoras' theorem, can I use it at all? 8, can I use any of those? No. But maybe I have this trick as well. I go back to the sine, the cos, and the tan. Can I use it? Sine, cos, and tan. Sine says opposite over hypotenuse. Cos says adjacent over hypotenuse. What bits do I know? Well, it looks like I know the value of opposite here is 6. And I know the value of adjacent is 8. So I know that the opposite is 6 and adjacent is 8. Are they linked anywhere here now? Is there anyone that has opposite and adjacent? And it looks like here in tan is opposite over adjacent, and you say that's great, okay. So the tan of this angle is this over this. We'll see if that helps. Well, tan A is opposite over adjacent. Opposite, adjacent. Tan A is 6 over 8, or 0.75. So I now can find tan of A. But the question I was asked for was to find A, not tan of A. But how can I get rid of tan? Well, if I was to do tan inverse here, tan inverse, I would just get A. So tan inverse of tan A is tan inverse of 0.75. They cancel. And this is on a calculator. I type in 0.75, hit second function tan or inverse tan, and I get my angle. So that's how I did that. Sometimes I can use the Pythagoras theorem. Sometimes I can use the trigonometric functions to solve it. So I didn't get the angle A first, I got the tan of it first. Now let's look at this question. Here we draw the triangle, and it's a right angle triangle, so this is 90 here. If that's 90 here, this is the hypotenuse. And it says, find the angle B. So in this case, we're not interested in this angle. So everything revolves around this one. So we start by drawing down the line from B, and we call that the opposite. And then this becomes the adjacent, not the other way around. So this is our Corach and this is Congrach. So because we've drawn from B, first thing you do, draw it out. Now we've got a right angle triangle with the sides. A is 6 and C is 10. So it looks like we know the adjacent and the hypotenuse. So we look here and see, is there a formula that links adjacent and hypotenuse? And we see it under cos. So cos would give me cos of b adjacent over hypotenuse. So cos of b is 6 over 10. For me to find b, I'll have to get rid of the cos. And to get rid of the cos, I say cos inverse of cos b is cos inverse of 0.6. They nicely cancel, and I end up with just 0.6, hit the calculator, and I get 53.13. And that's the end of that. Here's a fourth example. You've got a right angle triangle with A is 36.87. So it's giving me this number here. Find B. Well, this is very nice. I know this angle, 90. I know this angle, but I don't know this angle. And I want to find the angle B. Well, I go back to my sine cos tan. I don't think I need that, because I don't know any of the sides. But the angle rule, A plus B plus C equals 180. So the three angles, 1, 2, and 3, must equal 180. And I know two of them. So angles A plus B is 180. B must be 180. Taking the A across, minus A minus C. But I know A is 36.87, C is 90, and I just subtract them and I get 53.13. And that's the angle there. And this is the last on the right angle triangles. And we say, here's a right angle triangle. A is 6, sine B is 0.8, find C. How would you do that? So this is the last one, so see how we might do that. We know sine B. Well, if we know sine B, we should also be able to find B pretty okay. If we can, we should be able to find that. We should be able to find that angle, because if we took the inverse sine of it, we should be able to get just what the angle B is. But if that's the angle B, let's call that opposite. And let's call that adjacent, and let's call that hypotenuse. We are interested in finding this hypotenuse from this angle here. So let's see if we can find the angle B first. Solving for B, if sine B is 0.8, if I take the inverse sine of it, I get B is 53.13. So I now know the angle. I know that this is 6. I'm interested in the hypotenuse. And this is, remember, that's opposite. So this must be the adjacent. So can I link adjacent with hypotenuse? Adjacent with hypotenuse looks like it's cos. So if I was to take the cos of B, I would find that it's 6 over C. So cos of B, this is opposite, this is adjacent, and this is hypotenuse. Cos of B is adjacent over hypotenuse, it's 6 over C. I don't know the length of C yet. But cos of B, or cos of 53, I can get that on a calculator. So I know that the cos of that angle is 0.6. So 0.6 must be 6 over C. So I now have to solve that equation for C. So let's just take the equation. 6 over C is 0.6. How do I solve for C? If C is on the bottom, I don't like it. I'm going to bring it up to the top. So I'm going to multiply this side by C and this side by C, and they'll cancel. So 6 is equal to 0.6 C. I don't like 0.6 as a multiplier. I'm going to divide by 0.6 on both sides, and they'll cancel. So C is equal to 6 divided by 0.6, or 6 divided by 0.6. And 0.6 goes into 6 10 times. So 6 divided by C is that. Working it around, C is equal to 10. So we can take a breather there and look back at all the various things on the right angle. There were 5 different examples there. And what we've done is we've said sometimes they give us some of the angles and sometimes they give us some of the sides. So how do we do it? Well, if they give us 2 of the sides, we might use Pythagoras. Or we might use sine, cos, or tan to get the values of A or B. They might say sine B is this, and then we can get A or B. Or we might use the 180 rule. So remember that the angles may first need to be established from their trigonometric values. So sometimes they don't tell you that the angle is 30 degrees. They might say the sine of the angle is something. And then you have to work out what that is. But that's the full set of questions you can get on right-angled triangles. That's the full course on that. Now, it's not the full course on trigonometry, but it's the full course on right-angled triangles. So let's just take a recent exam question and see how they might do this. Generally, the right-angled triangle questions are nice and short. They don't have huge marks, but all marks count, and the techniques you'll use on the other ones later. So these questions are from 2019 or 2020, the last 2 papers. And let's just look at how they do it. I leave it to you to do. These are exam questions. You'll see them on the State Exams Commission. You'll have passed papers. All the solutions are on the State Exams website as well, so I haven't included them in your notes today. But 2 swimmers, A and B, stand at point X on one shore. It's a rectangular lake, and it's 100 wide. Both swim to the opposite side of the lake. Swimmer A swims to the left, making an angle of 55. degrees. Find the distance that A swims to the other side. So really all we're looking for here is that this is 100, this is 55, what is this length here? So I'll leave that with you for a moment. How do you do that? How do you find this length here? You don't know this one. And, well, you do know that angle, I suppose, because this is 90. But the way I would do this is I would start at the 55 and say, this must be the opposite. This must be the adjacent, and this must be the hypotenuse. Now we're interested in this length here, and we know the opposite. Opposite over hypotenuse, sine. Sine opposite over hypotenuse. So 100 over hypotenuse is equal to sine 55. Sine 55 is a number. 55, hit the calculator sign. 100 over hypotenuse, well, we don't know what hypotenuse is, but let's just say that's a number. Well, I'll plug it in. I'll do the calculator here if I can. I'll just pull up a calculator. I got 0.819 for that. So 100 over hypotenuse is 0.819. That's just an equation, and I'm asked to solve for hypotenuse. I don't like hypotenuse being on the bottom. I'm going to multiply on the top. So I'm going to get hypotenuse by 100 over hypotenuse. They'll cancel, is 0.819 hypotenuse. I don't like the 0.819, so I'm going to take that and divide it on both sides. So the hypotenuse is 100 divided by 0.819. And that's that question done. Now, the next part of that is swimmer B swims to the right and travels a distance 200 to reach the other side, making an angle of this to the bank. Okay? So what it's saying there is that swimmer B does something like this, swims to the right. We don't know the angle, but we know that that's 200, or we think it's 200, and we know that this is 100. That's 100 and that's 200. What's this angle here? I don't know. But if we're interested in that angle, we say this must be the opposite, and this must be hypotenuse, and this must be adjacent. If I know that this is 100 and that's 200, I know the opposite and the hypotenuse. Opposite and hypotenuse, that looks like sine to me. So sine looks like it's sine of this angle, whatever it is 100 over 200, which is 0.5. So sine of theta is 0.5. How do I find theta? I take the inverse sine of it. That's how you get rid of it. They'll cancel, and my answer will be put 0.5 into the calculator, press inverse sine, and you'll get your answer of that angle. And that's that question, question 5. The next day, the swimmers again swim to the opposite side of the lake, but in slightly different directions. Swimmer A swims to the left, making an angle of 45. Swimmer B swims to the right, making an angle of 40 with the side and the lakes, and travels 156 meters as shown. Find the distance both are apart. So here you're told this is 45 and this is 40. And you're told this length and this length. Find this length here. So you're given 1, 2, and 3. How do you find that length there? (45) and 40 is 85, and then take that from 180 and you're left with 95 degrees. Now, because this question is not a right angle triangle, you can't use Pythagoras and you can't use Sine Cos and Tan. So we're going to come back to that question and we'll use the formula in the next set to solve that. And that's it. Okay? So we're going to keep that because it's not 90 degrees. If that was 90 degrees, we could solve it. Okay? Now, so we've covered a fair bit of trigonometry. We're now going to turn to the bit that looks at triangles that are not 90 degrees. These rules apply for triangles that are like this, that are not 90, they're just ordinary triangles, the generic triangle. Each letter again though, A is opposite A, B is opposite B, and C is opposite C. The rules for triangles are as follows. You've got 3 rules, or 3.5 rules, or 4 rules, depending on how you call it. The first rule is that A plus B plus C, the 3 angles have to add up to 180. And there's also this rule called Cosine Rule, real and cohenous, and they say that A squared, the side A, when squared, is equal to the square of the B side, the C side, minus 2BC cos A. So that's an equation that tells you if you're looking for a side and you know the other 2 sides and the angle in between, you can use this formula. The cosine rule is also written like this, that says cosine A is b squared plus c squared minus a squared over 2bc. If you're looking for an angle and you know the three sides, don't need any of the sides, but you need an angle, you can use this equation here. This equation is actually the same as, they're both exactly the same equation. And just to give us some practice it, just showing how things work out there, a squared is equal to b squared plus c squared minus 2bc cos a. So just manipulating equations, just imagine you were just interested in the cos a. You would like that to be on the right hand side. So you say b squared plus c squared minus 2bc cos a is equal to a squared. You don't like the b squared plus c squared here, they're pluses, so you get rid of them and you make them minuses. You don't like the minus here because it's multiplying everything, so you change everything to minus, plus, and plus. So you end up with 2bc cos a is equal to b squared plus c squared minus a squared. You don't like 2bc on top, so you end up with cos a is equal to b squared plus c squared minus a squared over 2bc. So it's just the same equation, but they give it to you in two forms because sometimes you want to find an angle or the cos of an angle, and sometimes you want to find a length. And the third rule is real and teenish, the sine rule, that a side over the sine of the opposite angle is the same as another side over sine of its opposite angle, etc. for A, B, and C. So that's the sine rule. And one of these equations will help us solve the general triangles. Pythagoras doesn't work now because we don't have the 90 degree. So here's a typical structure of questions. You're given the question here and you're told you might be given some angles and some sides, and you've got to turn it into knowing all the angles and all the sides. It's a bit like Sudoku. You're going around the tables, you know some of the numbers and you're filling them in. And if you solve the question that way, you can then read out the answers really for the examiner. You just have to fill in the bits you don't know, step by step. So let's start here with the first example. You're given three sides, find the angle A. So given a triangle with the following values, A is 5.814, you're told this length, B is 7, and C is 8. So the three sides are known, and you're asked to find A. Find this angle here. So you go to your toolbox and you say, can I use the angle rule? A plus B plus C. I'd have to know two of the angles. I don't. Can I use the cosine rule? The side is equal to the two sides minus the cos. I'd have to know two of the sides. I do, but I'd have to know the angle A. I don't know the angle A. The third one, cos A says, if I know the three sides A, B, and C, I can find cos A. So this looks promising. So I can say, I know A, B, and C. I can find cos A. I won't find A, but I'll find cos A. So cos A is, again, I use this from the tables, B squared plus C squared minus A squared. So B squared, C squared, A squared over 2BC. So I just fill in the numbers. B was 7 squared, C was 8 squared, A was 5.814 squared over that. So I find cos A is 0.7071. How do I get rid of the cos? I do inverse cos. So inverse cos, again, makes that an A. An inverse cos of this, I just type in this in the calculator, hit second function cos or inverse cos, and I get 45. So that's it. So now I know the three sides and the one angle. So that's the first question. We now look at example 2. and we say two sides, and we've got a shared angle. So we know the 8 and the 7 and the number in between. So remember that if this is A, that must be the side A. B opposite B, C opposite C. So when they're talking about two sides and the angle in between, it must be BC and the angle A. It can't be the angle B, so B is over there. So it's the one in the middle. Okay, so we're given a triangle and we're told that's 45, so we know the three of those. Find A. So we go looking and we say we're looking for the length. A plus B plus C. Do I know two of the angles? No, can't use that. Cosine rule. To find a side, I need to know two other sides and the angle in between. Two other sides, the angle in between. Great. I can use the cosine rule, the first part. So, cosine rule here, I can say A squared is B squared plus C squared minus 2BC cos A. I'm just copying this down from the log tables. I'll get marks for that because I spotted the right one. I now slowly put in the numbers, and if I make a mistake, they'll still follow me, just a slip. But I put in 8 squared minus 7 squared minus that cos 45. Cos 45 on the calculator is that. A squared, when I add them all up, is that number there. I take the square root to get the answer, and I get 5.814. And that's how I got that. So now I know the length of that side A. So what else can they ask? Here they ask a question and they say two sides and the opposite angle. So we've got the angle 45. We're told that A is this. So that must, well, it's not opposite now, but that's A with A, and C with C, and B with B. So we've got that we don't know B or we don't know there, but we know C, and we don't know this angle. Find the angle C is what I'm looking for. So, can I use the three angles here? No, because I only know one of them. A squared, do I know two of the sides? I do, but I don't know the angle in between, so I can't use that one. Can I use the cos A one? No, because I don't know three of the sides. Well, then it's getting pretty stuck, so it better be this one. So A over sine A, B over sine B, C over sine C. I need to know three of these. I don't need to know six of them. And I don't know anything about B. I don't know the length or the angle. So I'll just put that out there. But A over sine A I know, and sine A I know. Well, I know the angle A, so I can find sine A. And C I know, and this I don't know. So if I've got an equation like that, where I only am missing one thing, I can solve that equation. Okay, so I'm going to use the sine rule. And the sine rule, A over sine A, B over sine B, C over sine C, I can get rid of that. A over sine A is 5.818 over sine 45, and 8 over sine C. Sine 45 is 0.7071. So now I have a number on this side, and 8 over sine C. That's just 8.222 over this. I don't like sine C on the bottom. I'm going to multiply it up on the top, so it goes up on the top, and that 8 becomes 8. Don't like this number. I'm going to divide it on the bottom, and I end up with 0.972. But that's sine C. I'm interested in C. So I have to now get the inverse sine of that. So to get rid of the sine C, I take the inverse sine of it, just as I did here to get rid of it, and I end up with 76.64. So what you've seen there is a step-by-step approach that says, what have they given me? What do I know? What do I need to fill in? What's missing? So the approach to questions are, if there's 180, if they give you two of the angles, you can find the other through the 180 rule, as we did for the right angle triangle. If they give you two of the sides and the angle in between, so there's AB and the angle C, you can use the cosine rule. If they give you 3 of the sides, you can use the cosine rule. Or if they give you the 2 of the sides and 1 of the angles opposite 1 of the sides, you can use the sine rule. Or if they give you 2 of the angles, maybe, or that's 2 of the angles. If they give you 2 of the sides, you can find and 1 of the angles, you can do it that way as well. So that's the way you can use all of those, and you'll always find an answer. That's the end of that. Let's go back to the questions now that we were doing and just see if we can finish the rest of that one that came up. Here we were saying the next day the swimmers swam again, and they were going, one swimmer went 45 degrees, the other went 40. Well, I think that given that the angle on a line is 180, then these 3 angles must equal to 180. So 45 and 40 is 85. Add 95, you get the remainder. What we're doing now is we're trying to find that length there. So what do we know? We know side A, side B, and angle C. So we've got 2 sides and the angle in between. 2 sides and the angle in between. So we can look at the actual formula for that, but we should be able to find that we can use one of the cosine rules for that. And 2 sides with the angle in between, and we're away. So that's how we solved that particular question. I've just put away the handbook, the note that I had on that, but it's the one we've been using all the time. So what do we say? 2 sides and the angle in between. We can find the other length. So we can find that length here, this length, by saying a squared plus b squared minus 2bc, 2ab cos c. And that's our length there. And that was the end of that question. Now, just do a few more small endings of triangles, and then we'll come back onto the fuller questions that they give you where there's a lot more marks. A few more equations, not many, but this is the area of triangles, just in case this comes up. The area of a triangle, your note on this, again, you might highlight this and keep this as a page. Again, all of these are in the tables, so you can just refer to these and have them highlighted or remember where they are, so that when you open the book in the exam or in school or wherever you're doing it, you'll be able to draw on it. But the area is 1 over 2 AB sine C, 1 over 2 BC sine A, or 1 over 2 AC sine B. Or the area is half the base by the perpendicular height. So let's look at that for an equation here. Here's a triangle. If I wanted to find the area of that triangle, I could say it's a half A by B by the angle in between, or a half C by B by the angle in between, or a half C by A by the angle in between. Any one of those will work. Or if I want to do it with perpendicular height, I can say it's a half the length by the perpendicular height here. So there's 2 ways of doing it. So if I was given all the measurements here of this being 10 and that being 2, so 10 to there and then 2, that's 12 in total. I can say the area is half of 12 by this height here. I'd have to find, well, I'll do it by the sine and then I'll do it with the other one later. So that's on the next page. So if I were to do this here, half AB sine C, I say a half of A, which is this one here, that length there, 12. This one here, 12.81 by sine of the angle in between. So the area is half of 1 by the other by the other. So I know the length B is 12. I know that C is 12.81. I know that that's sine A. The other way of doing it, if I knew the height, I could say it's a half of 12 by the vertical height, 8, and solve it that way as well if I was told that. Okay, so there's 2 ways of finding the area. Now, how do they make a question out of this for us? And we'll show you how these work out in the longer questions that have come up recently. Here's an example of trigonometry and just linking it with circles as well. So just a very quick summary of what a circle is. Here's a circle, your circle, and it's got a perimeter, 2 pi r. That's the imlina. So you're looking at the perimeter, that's the length going around, 2 times pi times the radius. And the area of a circle is pi r squared. Note that r squared, think about it as meter squared, so meter squared would be a square area, whereas r would be meters, and that would be just the length. So that's the perimeter, and that's the area of the circle. That's the full area of the perimeter and the full area of the circle. But if you're only dealing with a small part of it, or maybe you've got an angle there, and maybe it's the angle A, well, you've only got a small bit of the circle. So the way it works out is that 360 is the total number of angles in a whole circle. And if you're just got A of those, let's say it's 90 or something like that, then you'd have 90 over 360, or a quarter of the actual circle. If A was only 10 and it was a tiny amount, you'd only have a very small sliver of a slice of it. And the area, so the length here is, instead of 2 pi r in terms of length, it's only this proportion of the length. So if it's 90 over 360, it'd be a quarter. If it's only a tiny bit, it's only this amount here. So if that was 10 degrees, it would only be a 36th of the whole lot. And the area of the sector, all of this area here, is given by, again, the proportion, how much of the 360 is covered. So if it's A over 360, if A was 90, it would be a quarter of the circle. If A was a tiny bit, it would be only a small bit. So there's the equation, the perimeter of the circle, the area of the circle, and the length of the arc. All they're saying is that if you don't have the full 360, you get that proportion of it. So if it was 180 over 360, you'd get half the circle. And similarly, you get half the area. So here's an exam question that came up a long time ago, but it's in the syllabus, but they're using exactly the same ones again. So I'll just use this as an example of how it works. What they do is they try to find this shape, and they make a distinction between the triangle here and the sector, the cone. So imagine this is sort of a very fat ice cream, I suppose. You've got some ice cream on the top, and there's the cone or whatever, slightly misshapen. So the question is, find the size of the area shaded red. Start by finding the area of the sector. So really what you're asked to do is, how do you find the area in the red bit? Well, the area of the red bit, it's really like a bit of a circle, because it's part of the whole circle. Now, it depends on how big this angle here. But if this angle is 90 degrees, that means that there's it's a quarter of the circle. 1, 2, 3, 4. So this is a quarter of the circle because it's 90 over 360. If it was a smaller number, it'd be less than that. So it's a quarter of the circle. So what is the area of the circle? Well, we look at the equations for that. It's in the tables. Pi r squared is the area of the circle. But if it's only 90 over that, that's the area of the sector. So I get pi, or the radius is 20, squared. And then I've got to multiply that by 90 over 360. So 90 over 360 by pi r squared, but pi 20 squared. 20 by 20 is 400, and that's divided by 4. So 100 pi. So that's 100 pi, the whole lot, in that quarter. Now what's the area of the triangle? The area of the triangle is the green one, just the green shape. And how do I find that? Well, let's just separate it for a minute and just see if we can just draw it, and imagine that that's the area of the triangle. This was 90 degrees, this was 20, and this was 20. The area of the triangle is given by half AB sine C. We know that that's a 90 degrees. So it'll be a half 20, 20 sine of 90. sine of 90 is 1. Or you could have turned it like this and said, given that it's a 90-degree triangle, then it's a half the length by the perpendicular height. So it's a half 20 by 20. And that turns out to be half 20 by 20 is half of 400, which is 200. So the green bit is 200, and the total bit is, I think, 100 pi. So the shaded area in red is the 100 pi, the whole lot of it, minus the 200. And that's how they get you to do those questions. They ask you to separate it into various chunks so you can actually figure out which is which. And finally, before we move on to the questions, I just want to show another part that they use. Some mathematics relates to moving around the world, and the first mathematicians, I suppose, were the navigators who went around the globe, and they used, instead of x and y, which we're used to from mathematics, they use x and y. People around the navigators in the past went with north, south, east and west. And that was their compass or their way of writing numbers in that way. Now, just when it comes to north, south, east and west, when we talk about x, y, we always think about, if somebody said, where's the point 3, 2? We would always start by going out 3 and up 2, 3, 2, always x first and then y. But when it comes to navigation, we do it the other way around. We always talk about north, south first before we talk about east and west. So when somebody says, where's the wind coming from? You'll hear the term southwest, or you'll hear the term northeast. You'll never hear words like west-south or east-north. It's just not the way we do it. It's in a different order. So when we talk about moving around a two-dimensional space like this, with north, south, east and west compass directions, we go vertical first and then horizontal. So let's see how that works. Here's a point here, and we say, how do we get to this point 3, 3? Well, we don't say, well, it's somewhere over here in the northeast, all right. But what we say is we go up north first, and then we turn. So if this was the same 3 and 3, we'd say up north and then 45 degrees east. So n 45 east means I go up north, I turn here from the north through 45 degrees to get where I'm going. So I'm traveling north 45 degrees east. In this case here, I'm traveling, where's that? Well, to get to that point in XY, I'd normally go this way, but here I have to go south first and then turn. So I go south, turn through the angle 63.44 to find that point there. So that's how they define them on a compass set. Now I'll just go back through some special angles. There's a 30, 45 and a 60-degree angle. The 45 is very handy because if this is 90 and that's 45, this must be 45. So if these two angles are the same, the lengths of the side opposite must be the same. So they must be 1. So that must be an isosceles triangle or a triangle cosine. Sorry. If we look at this now, in this case here, we've got 1, 1 and root 2 over 4, or sorry, root 2. So that's our standard. It was very simple for people designing, you know, shapes way back. They just have a plank and a plank the same length at 90 degrees, and then you had your nice triangle there, and this was the square root of 2. Why is that the square root of 2? Because 1 squared and 1 squared would give you 1 would give you 2, and this must be, and the square root of 2 would give you 2. So that's your Pythagoras. Sine of 45, if this is your 45, that's your opposite over your hypotenuse, is 0.7071. Cos is adjacent over hypotenuse, and tan is 1. This was another relatively easy thing to do. You get a piece of length too long, 2, 2, and 2. Join them together, they're all the same. So this length is the same as this. The angles are all the same. So those angles must be the same. And that's, an equilateral triangle or a 3-and-ton cohomologic. If you have it, you'll end up with 1 here, 2. So what's this length here? Well, we don't know, let's say, but 1 squared plus x squared is 2 squared. 1 plus x squared is 4. X squared is 4 minus 1. X squared is 3. X is the square root of 3. And that's how we would get that from Pythagoras, because that's 90 degrees. And again, if that's 90 degrees here and 60 is there, that's your opposite and your hypotenuse, and you can get your sine, your cos, and your tan from it. Also, if you've got a 60-degree angle, you have a 30-degree angle up here. So once you've done that, because that's 90. So if you wanted to find the cos of 30, you'd call this the opposite, this the adjacent, and that's the hypotenuse. And you could find out which one you wanted to do if you want to get the sine, cos, or tan of 30. So again, you could do that. That's opposite, that's adjacent, and that's hypotenuse. And again, you can calculate those. And that's it. So, where do we go with the questions now? So we're going to take a break, and we're just going to just see where all of this fits in, and just to show how, I suppose, you can get 55-mark questions done by going through the Sudoku method of saying, what do I know? What's the next step? Where do I go? Etc. So these 2 questions, I think, are taken from 2019, 2020. But if you go back through all the years, they're all the same. Back to 2015 when your new syllabus came in, and they can't change the syllabus. So it'll be similar questions that you'll have if you're doing the leaving cert, or if you're taking calculated grades and you've got exams or tests or teachers' verdicts and stuff like that. This will all help. So, thank you. We're going to go with the last 2, and we'll be finished by 3:30. Okay, so this is question 9. You'll be able to find this on the state exams questions, and you'll also be able to find the solutions there as well. Or is a radar station located 120 kilometers north of port P. The circle C centered at R with radius that shows the detention range of the radar. When a ship enters the circle, it'll be detected by the radar station. So you have a big circle here. I'll just draw it slightly larger. And you've got a point here, P, and here's your R. And what's happening here is that this ship is sailing here, and it's going to be detected in this area here. Once it gets into this spot, it's going to be detected. So as you sail up here, now you're also told, I think, that this is 30 degrees. So that's fine. So R is the radar station, and it's 120, this is 120 kilometers north. So that distance you're told. Figure 1 shows a ship leaving port C and sailing. The ship enters the circle at S and exits at T. So this is point S, and this is point T. Now remember, there's 55 marks for this, so you'll have a lot of time to be able to do this in the exam. Now, the triangle PQR taken from figure 1 is shown in figure 2. Find QR and the length of QR. So what they're doing in all these parts is they're taking you step by step by step through the particular calculations, so it can help you with it. So it's going to say the triangle PQR is shown here, and you're asked to see if you can solve it. So let's look at it here. We've got this triangle here quite large. So we're told that this distance here is 120. We're out here at an angle 30. And this is 90 degrees. So we're told this is 90. This is 30. And we're asked, find QR, the length of this. So this is R, this is Q, and that's P. So have a think about that for a minute and just see how would you find that length there. Well, we might just call the things A, B, and C if we'd like. We might call this C and this angle C. We might call this A and side A, because they're opposite, remember, and they're opposite. And then this must be the side B, and this must be angle B. And let's see which ones we know. Well, we know that C is known, that's a tick. We know that A is known, that's a tick, and B we don't know. A we're looking for, B we're looking for, but C we know. So we look at that pattern and we say, how do we solve that? Well, there's a few ways of doing this even before it's 90 degrees, but if it wasn't a 90 degree, we could still solve it. We could say, well, we know a length and an angle, and an angle and not a length. So the three of those four together, and we can use the sine rule. So we could use the sine rule, sine A over A, or sine A over A equals sine C over C, and we could solve it and we could get A. Is there a way we could do it with the 90 degree angle? Let's see. Is there a way of doing that? Is there anything else we could add? Well, let's see if we draw it again. Let's say that's a 90 degree angle. Well, if it is a 90 degree angle and that's 30 and that's 60 or whatever it is, and we know this length here, let's say we take 30 as the angle of interest and we call this opposite and this adjacent and this hypotenuse. Is there anything that, let's say we know this length, we know that this length here is 120. So we know the hypotenuse. So we know that the hypotenuse is 120. And let's say we're interested in opposite. Is there anything that has opposite and hypotenuse together? We look up the notes and we say opposite over hypotenuse is sine. So sine of 30 is opposite, we don't know, over 120. Sine of 30, 30 is a number. Hit the sine, you get a number. 120 is a number. We should be able to solve that. So really we can solve that distance either through the sine rule or through the other rule. So we're on the way. We now know this length PQ. The angle QRS taken from figure 1 is shown in figure 3. Use your answer to find QS. So what they've done now is that, given that I found out that length, they're interested in me finding out about this length. What's this length here? What's that length here? How do I find that? Well, the only thing I know about it is that's a radius. And that I now know. Let's say I know that that angle I think is 60 kilometers. That's what it works out as. So now I have a triangle that is neat enough. I know that I don't know this length, but I know one and I know the other because that's the radius. So if I've got a triangle where I know this length and I know this length, and I know that that's 90, it doesn't matter, I know the angle. Can I find this length? Well, not only do I find that I find it's 90. So what have I got? If I call this A, or sorry, let's call that C, capital C, B, capital B, A, capital A. I look and I say I've got A, B, and C, A, B, and C. That angle I know, sorry, that angle I don't know. I know the C angle is 90. I know the length of C. I know the B. So if I have two lengths, I can find this angle, and this length. So again, I use exactly the same thing and I can go around and I can find QS. So you give your answer to the nearest kilometre, and I do. Now consider the triangle. Use the cosine rule to find an expression for cos. So here we have now, we've got the circle again. I'll just draw it. Center in the middle. I know this length. I know that's the radius, 100. I know this is 100. If I know the three sides, can I find the angle? I look up the equations that I had. The cosine, if I know the three sides, I can find the angle. So then I find the angle for that. John sails directly from S to T. Mary sails around the corner. So John sails the first length, which we just found out, and this sails around the other. But we know the angle in the middle. So we find now that we've got this circle, or bit of a circle, sector. It's 106 degrees that we've worked out. John is sailing this way. Mary's sailing that way. How do we find the length of that? Well, we know the length of a circle, the perimeter, is 2 pi r. We know that 2 pi r is 2 pi, and the r was 100. That's fine. But we don't have the full circle. We only have 106 degrees of it, times 106 over 360. And that tells you the length Mary's travelled compared to John. And the last one, the sea in this region is estimated to have an average of one ship per 25 square kilometres. Find the number of ships in this area. Again, you say, I've covered everything. I have to be able to answer it and pick up the marks. It's got to be one of the formulae. So this is an area question. It's an area about a circle. It's only half a circle, or a bit of a circle, so it's a sector. So it's pi r squared is the area of a circle, times the angle, a over 360 or whatever that was, and the angle is 106. So that's the amount of area in that space. And then say, fine, that's the area in the space, and then if there's one ship for every 25, divide by 25. And that's that. So you can see how you can get 55 marks without a problem, really, by just doing 1, 2, 3, 4, 5. You go through the steps. What do I know? What bit can I use? What formula do I use? Plug in the answers, go around the houses, and then you've got it. So with the last few minutes, I'll just do the very last question. I think this is the other year, 2020 or 2019. And just to show the process again, so you're completely comfortable with these questions. A vertical mobile phone mast of height h is secured with two cables. So here's your mobile phone mast, and it's supported by two cables, this one here and this one here. This is at 30 degrees and this is at 45 degrees. Explain why this angle here is 105. So you know that the three angles must equal to 180. So 180 minus 45 minus 30 is 105. And you say that's the general rule. The three angles have to add to 180. And that's your first answer. Nice marks for that. The horizontal distance from A to B here, is 100 meters. Use your triangle to find the length of y. What's this length? Again, you can go A, B, and C if you want. You can call that A. You can call that the length A, so that would be the angle A. This would be B, the angle B, and this would be C, and the side C. So what have we got? We've got A, B, and C, A, B, and C. What do I know? I know the length of A, don't know B, and don't know C. But I do know the three angles. So I can use the sine rule to get any of the others. So give your answer to correct. So that allows me to get B, or Y in this case. Use your answer to find the values of H and the values of X. So how do I find the value of X? It's exactly the same, the sine rule, so that'll be finding C. Same thing again. And how would I find this value here? How would I find that height value there? Well, we can look at it and we can say, what would I know at that stage? Well, given that that's vertical, I know that it's a 90 degree. 90 degree. I know that this is 30, and I know the length of this one, and I know that. So again, there's loads of ways I can do that. I know if this was C, A, B, and B, A, B, and C, I would know the length of C, and A, B, and C, I would know the angle A, and I would know the angle C. So I have two angles and a side. I can use the sine rule. Or there's other ways as well. I could look at this and I can say, if I look at the angle 30, given that it's a 90 degree angle, a 90 degree triangle, if this is 30, and I know the length of this thing here, C, I can say that's the opposite, that's the adjacent, and that's the hypotenuse. If I'm interested in this length here, I'm interested in opposite, I know hypotenuse. So opposite over hypotenuse is the sine of 30. 30 is a number, sine I can get, that's my answer. Opposite I don't know, hypothesis I do know, and I can solve it. So again, I've solved that. So that's the two values there for H as well. And the last bit is, the mast can provide a strong signal for an area in the shape of a rectangular hexagon. So there's the mast, and you're asked to find the area of the hexagon. Well, area of a hexagon. You've got a triangle, 8, 8, and a hexagon. Sorry, that's 8, and that's 8, and that's 8. What's the area of the triangle? Well, there was an equation for that. I think it was a half AB sine C, or a half A, the base by the perpendicular height. But I think it's much easier to do half AB sine C. If the three sides are 8, then the three angles must be 60. So it's a half AB sine 60. A is 8, B is 8, sine 60. So that's the area of the triangle. A circle touches all the vertices of the hexagon, can show areas where the signal is weak. So here we've got this area outside that. So it's like a triangle, but it has a bit on the outside. Exactly the same as the ice cream cone we did before. And it says, okay, find the shaded area here. Find the shaded area here. Well, we don't know how to do the shaded areas on its own, but we could find it as a part of a bit of a circle. If it's a hexagon, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, hexagon, what have we got? 1, 2, 3, 4, 5, 6. So there's 6 parts to it. So whatever the circle is, it should be a sixth of the whole circle. So the sixth of the whole circle would give us 60 over 360. 1/6 of the whole circle. The area of the circle would be pi r squared, which would be pi 8 squared. But we only have a sixth of it for that bit. And that covers the whole lot. And then we take away the area of the triangle. The area of the triangle was 1/2 times 8 times 8 sine the angle in between. And that's how we get that bit. So give your answer one of the shaded areas. So hopefully all of that makes some sense. What I was trying to do today was to fill in some gaps on the various topics you were doing. Look at the trigonometry and show that you go in there with a bag of tools. You say, what are my formula that I can use? The sine, the cos, the tan. What are my equations for the area of a triangle? What are my, step-by-step approach? What can I use? Can I use the cosine rule? Can I use the sine rule or whatever? So, but every single question for the last forever can be solved with the techniques that you've done. So the trigonometry is complete. Learn the steps in it. Practice 1 or 2 of the questions. I know I went through them a bit quickly because you do them with much more time in the exam. But any question you can't do, look at the solutions on the state exams board. But just trust yourself step by step by step. And everything you write down, everything you attempt, you get marks for. So thank you very much. I'm going to come back here now and have a chat with you and just say goodbye for that. And we're going to start again at 4 o'clock. We're going to do a lovely, lovely topic called complex numbers, and that will conclude the session for today. So, Gurmil Magav, Asokt Eishterklum. I hope some of that joined in some of the dots and that you're in a better place to face the maths for the remainder of the year. So, Slán go fóill.